reinforcement pipeline, as I talked about, this is what if I were to see it from a bird's eye view, this is how it works in industry, in governance, and with all the tech tools we have. So it starts with the data streaming and data ingestion process. So data streaming and ingestion can happen at a real-time level. So real-time level is the data which is constantly flowing in. So just like Facebook, it has this real-time data constantly flowing in, which is being used for sentiment analysis. So and apart from this, you can divide the data into structured and unstructured. Unstructured is the CSV file or the Excel file you get in case. Unstructured data is are the images, the audio clips, or maybe the text data you have, right? Since there's no associated structure or the columns based approach you can have to train the data set on, right? And you have relationship database management systems, which are nothing but SQL databases which have relationships between three different data sets, right? And then you have columnar storage, which helps in increasing the processing power while dealing with big data, right? So after you ingest the data and you have it ready, you perform multiple operations on it to see whether the data is consumable or not. Let's say you have a column in a data set which is totally blank, right? So that's not suitable for processing and might hinder the process or hinder the computational capacity. So it's about fixing the missing values. So while fixing the missing values, you have multiple approaches of like imputing it with the average of the entire data set or the median of the data set, and it all again depends on the use case, right? That's where the design thinking mindset comes into picture, right? So let's say if I talk about the power generation demand for one particular month, and let's say it was observing a constant trend over time, and there was one particular day for which I don't have the consumption available, right? So since the data was maintaining a constant trend, so I can directly impute it with the median of data set, right? So that's how fixing missing values works. And then reformatting the columns, the data you get. So it's like if you want to resample the data set, let's say you had it at a seconds level, but you want to see it at an hourly level. So that's where the reformatting comes into picture. Removing duplicates, so they always make, if you have multiple duplicates for one data point, so will make the system biased and won't generate the right prediction. Then you have something like transforming variables. So transforming variables is like when you, so I guess you must have seen the coronavirus projection chart, right? So if you see it at a linear scale, it seems exponential, and when you take the log of it, it seems linear. So linear, and there's a flattening effect being observed. So that's a way of making the output variable or the output target more understandable and more consumable, right? And resampling, as I talked about, is maintaining the class balance and other things. So the data should be balanced, right? So let's say you have a data set for fraud detection, and you have only one record in which a fraud happened, and all other data points are fine, right? In a data set of 2,000 rows. So we can't directly use this data set until and unless we resample it, right? So normalization is a process of making the data, scaling the data set, so that if we were talking about thousands and 10,000s, if you want to reduce the scale to 0 to 1, that's where normalization fits in. So I know I'm talking a lot of technical terms. For folks who are not aware of all these terms, you may search for it after this webinar, right? And feel free to reach out to me if you have any issues, right? And so coming back to data wrangling, after this is done, the data preparation or data cleaning is done, it is sent for feature engineering. So there are multiple situations in which we have like 10,000 features, 10,000 columns. So you can directly input it to a machine learning model for learning, right? You need to reduce the number of features in order to have a best optimal performance, because it requires a good level of computational capacity, right? So it's always wise enough to engineer the feature and select the best features, right? So you have techniques like feature binning. It's like changing a continuous variable to a categorical variable. Let's say I have the age of customer, right? So I want to bin it in three buckets. So that's how, like, I'll say young, medium, old, something like that, right? And feature selection is the process of selecting the best features from the given data set. It has multiple techniques like correlation, plotting a correlation matrix, dropping columns having high collinearity, and then you have other feature selection techniques like random forest selection tool, etc. So dimensionality reduction, it's an advanced topic built over feature selection where, let's say what was happening is, while you had 10,000 features and you retained only 20 features, you might be losing out on some critical information, right? So in order to circumvent that, there's a technique known as dimensionality reduction, and PCA is one of the feature of it. So in this principal component analysis, you derive 20 variables, which is a combination of those 10,000 variables, right? So in this way, you tend to preserve information of each and every feature, and at the same time, not make it computationally intensive, right? So, and the final process of model development, which takes place, is that when you have the entire data set, and you develop the model, you just don't want to have you just don't want to have a fluke model which performs well on the training data set, right? So you divide the data set on the basis of the split criterion. So it's generally we have 70 to 80% of the data as the training data set and remaining portion as the test data set. So training is the data set where you perform the feature engineering part, right? And that's where your machine learning algorithm like regression or classification fits in, and then it generates predictions for both the trained dataset and the test dataset. So the performance metrics on trained dataset will help you understand that how well your model fits in on the basis of its training, right? And the test datasets will help you understand whether the model was conducive to changes in the new dataset or not, right? And that's how we have the evaluation of metrics, and then we deploy the model on the server. And as I mentioned, it is a continuous process, right? Modeling is a continuous process, so we constantly assess the model, right? So with the situations changing, is it reacting perfectly to the environment or not, right? And so coming to the tech stack, I think you'll be excited to hear about on the tools that exist. So when we talk about big data tools, so while working on some of the projects, I've handled text files which were 90 GB, right? So that is something you can't load it directly into your system. You need a cloud infrastructure for this, and that's where the big data tools come into picture. So so Hadoop infrastructure is about having distributed storage and distributed computing. So essentially, the infrastructure we have these days in markets is like we have 250 GB RAM computer, 4 different computers which work parallelly. So that's where the idea of parallel processing comes into picture, right? And in order to interact with the interface, we have languages like Hive, Spark, and Scala, right? And once you are done with handling these multiple data sets and you want to understand the data or create some visualization, so that's where PySpark or other coding languages, Python, R, and SAS comes into picture, right? They help you understand or get the sense of the data. And then we have data visualization tools. So these are the dashboards you see, right? They can be built in multiple languages, but specifically if we talk about the business analytics or data analytics domain, these are some of the major tools which are used, right? And finally, there are some of these companies which have set up the cloud infrastructure and have enabled better processing of data. That is Microsoft Azure. So their cloud infrastructure um, covers the entire process, right? So end to end, from generating results to having a constantly retraining based model environment where a model after deployment is getting retrained as soon as the new data steps in, right? And then you have Amazon workspaces. So they are running neck and neck when we talk about cloud analytics space.